how to differentiate inverse trigonometric functions. Now, the three basic trigonometric functions that we have are sine, cosine, and tangent. So their inverse will be sine inverse, cos inverse, and tan inverse. So how do we differentiate inverse trigonometric functions? Take, for example, you are given y is equal to sine inverse of s, and you are asked to differentiate it, that is, find the derivative dy dx. How do we differentiate y is equal to sine inverse of s? Now, there are three basic steps you just need to know. Once you know how to apply them, then there you are. The first step you need to apply here is y. This statement y is equal to sine inverse of s, write it as a direct statement. In other words, write this inverse statement as a direct statement. So if y is equal to sine inverse of s, the first step is s will now be equal to sine y, by writing this as a direct statement. Now, the next step is differentiate this. S is equal to sine y, differentiate it. That is, you are differentiating sine y with respect to what? To y. So when you differentiate this, you will get the s dy. So differentiating s with respect to y, the s dy will give us, if you differentiate sine, it will give you cos. So sine y will give us cos y. So our ds dy is equal to cos y. If ds dy is equal to cos y, this implies that dy ds will give us the reciprocal of this. The reciprocal of ds dy will give us dy ds. So that means it's going to give us 1 over cos y. So we have our dy ds to be equal to this 1 over cos y. Now, the next step is, from our knowledge of trigonometry, we are going to express cos y in terms of s. Now, we know from trig identities that cos square y plus sine square y is equal to 1 from trig identity. If this is true, this implies that cos square y, making cos square y the subject of the formula, is equal to 1, then this sine square y will cross to the other side, minus sine square y. So our cos square y is equal to 1 minus sine square y. So to get only cos y, this implies that cos y will give us 1 minus sine square y, or in square root. That is, to remove this square is to take the square root of both sides. If you do that, this square root and this square will go, so that our cos y will give us 1 minus sine square y. Okay. But from here, you know this one can be written as 1 minus sine y all squared. It's the same thing. But we know that sine y, from here we said s is equal to sine y. So representing this now with s, this implies that this can be written as 1 minus, instead of sine y is s squared. So we are saying our cos y can be written as 1 minus s squared. That is writing it in terms of what? Of s. Therefore, our dy ds, which is equal to this 1 over cos y, can now be written in terms of s. 1 over, instead of cos y, our cos y is this 1 minus s squared. So, in summary, the derivative of sine inverse of s is going to give us 1 over square root of 1 minus s squared. Similarly, you are given another example. Y is equal to cos inverse of s, and you are asked to find the derivative dy ds. Now we apply the same steps. The first step said, write this inverse statement as a direct statement. So if y is equal to cos inverse of s, this implies that s is equal to cos y. So you first of all write this inverse statement as a direct statement. Now the next step we said differentiate s with respect to y. So differentiating this with respect to y is going to give us ds dy is equal to, if you differentiate cos y, cos will give us minus sine. So it's going to give us minus sine y. So that our ds dy is equal to minus sine y. So if ds dy is equal to minus sine y, that means our dy ds is the reciprocal of ds dy that will give us dy ds. So it's to take the reciprocal of this. So it's going to give us minus 1 over sine y. Taking the reciprocal, the inverse of this will give us this, to get our dy ds. Now we've gotten our dy ds to be this. Now the next step is, we express our sine y in terms of s. How do we do that? Recall from our knowledge of trig identity that cos square y plus sine square y is equal to 1. So this implies that making sine square y the subject of the formula, sine square y is equal to 1, then this cos square y will cross to the other side, change to minus cos square y. So that our sine square y is equal to 1 minus cos square y. So if sine square y is equal to 1 minus cos square y, this implies that sine y is equal to square root of 1 minus cos square y. Because by taking the square root of both sides, this square root and this square will go, so that we are left with sine y is equal to the square root of 1 minus cos square y. And this can also be written as 1 minus cos square y is the same as cos y all squared. But recall, from here we said our s is equal to cos y. So writing cos y in terms of s, instead of cos y, now we can replace or substitute the cos y with s. So this implies that 1 minus cos y square can be written as 1 minus our cos y is s. It's going to be s squared. So we are saying that our sin y is equal to square root of 1 minus s squared. Therefore, our dy ds from here, we said is equal to minus 1 over sin y. But we said we are to replace or express sin y in terms of s. So whenever we see sin y, we are going to use this. So it's going to be 1 minus s squared. So in summary, that is the derivative of cos inverse of s is going to give us minus 1 over square root of 1 minus s squared. Now let's consider the one of tan. Example 3. Given that y is equal to tan inverse of s, we are asked to find the derivative dy ds. Now we apply the same steps. Solution. We said write this inverse statement as a direct statement. So that means s is equal to tan y. Now the next thing is differentiate s with respect to y to get your ds dy. So that this becomes ds dy is equal to. Now if you differentiate tan, it's going to give you sec square. So the derivative of tan y is going to give us sec square y. So our ds dy is equal to sec square y. This implies that our dy ds is equal to the inverse or reciprocal of this. So it's going to give us 1 over sec square y. Now this is our derivative. Now the last step we said is express sec square y in terms of s. How do we do that? Recall from our knowledge of trig identity. We know that the second trig identity is 1 plus tan square y is going to give us sec square y from our knowledge of trig. So that means wherever I see sec square y, I can replace it with 1 plus tan square y from here. But recall, remember this one can be written as 1 plus tan square y is the same as saying tan y all squared is equal to sec square y. So replacing sec square y with this, that means whenever we see sec square y, we can write in this place 1 plus tan square y. But recall, from here we said our s is equal to tan y. So that means this can be written as 1 plus our s, which is now tan y. So it's going to be 1 plus s squared is equal to sec square y. So we are going to substitute this into our dy ds here. So with this now, this implies that our dy ds from our knowledge of trig identity, which is equal to this 1 over sec square y, can now be written as 1 over our sec square y. We are going to express it in terms of s, which is equal to this 1 plus s squared. So in a summary, the derivative of tan inverse of s is going to give us 1 over 1 plus s squared. So those are the 3 steps you just need to apply. The first step is to differentiate inverse trigonometric function. Write the inverse statement as the direct statement. Then the second step, differentiate that direct statement with respect to, in this case now, differentiate it with respect to y to get your ds, dy, and then the reciprocal to get your dy, dx. Then you recall from your knowledge of trig and then express the function here in terms of s, and then you are done. Thank you so much.